Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about geometry. Now the question that I've chosen to go through here is 2019 Paper 2 Question 5 Part B. In this question we're given the following diagram. A bunch of triangles and a circle. We're asked to find the angle BEA, so the angle out here. Now it's really important you realise the nomenclature they use in the question, like they say that the distance, they use distance lines and they say the distance CD is equal to half the distance AB. Because they use that kind of terminology, that means in your solution you have to use similar terminology. Every time that you say this angle, every time you find a side or an angle, you have to justify it. So the vast majority of the marks here are actually going for your justifications. So let's work through this. First of all, the most important thing is that they've told you that the distance CD is half of the distance AB. Clearly, half of the distance AB is the distance AO. AB is a diameter, so half of that distance is AO, or in other words, a radius. So the first thing that you would say is that the distance AO is equal to the distance CD. Now, your justification for that is it was given to you in the question. You can just say, all you have to say to justify that is that it was given. So AO is a radius, so obviously by extension CD is the same length as the radius. So if CD is the same length as the radius, well, let's have a look at the triangle ODC. The triangle ODC, OD is a radius, OC is a radius, and I've just after working out that CD is the same distance as AO, because they're all the same distance. So what I would say next is I would say that therefore I can conclude the distance OD is equal to the distance OC, which is equal to the distance DC. Happy days, they're all radii. So in that case, all radius distance. I wouldn't actually say that they're all radii because technically CD is not actually the radius of the circle, but it's the same distance. So I could say that OD equals OC equals DC. If all three sides in this triangle are the same, my next thing I can conclude is that the triangle ODC must be an equilateral triangle. If all the sides are the same, then obviously that means all of the angles are the same. The three angles have to add up to 180 degrees, so I could say that all three of these angles are 60 degrees. That's just, it's sufficient to just say ODC is an equilateral, and I can label all of those as 60 degrees. Now the next thing that I'm concerned with is they told me that the line CD is parallel to the line BA. If that line and that line are parallel, once you have the presence of parallel lines in geometry, you should always be looking for either alternate angles or corresponding angles. In this case, there's alternate angles that are relevant. I know that that angle, the angle ODC, is the same as this angle, the angle DOA. They're alternate angles, or a lot of people think of them as Z angles. They form kind of a Z shape. They're alternate because AB and DC are parallel. So that's my next thing. The next thing I would say is that the angle ODC is equal to the angle DOA is equal to 60 degrees. They're all 60 degrees. And my justification for that is that they're alternate angles. So I can say, okay, they're alternate angles. Every time I write something down, I have to justify it. So happy days, I now know that this is 60 degrees. Now I'm running out of space, so I'm going to start again from the top. Okay, so I've worked out the angle DOA is 60 degrees. The next thing I'm going to say is, I can say the distance OD and the distance OA are the same. The reason they're both the same is because they're both radii. So I can say that OA is equal to OD because they're both radii. If a triangle has two sides that are equal to each other, that means that it's an isosceles triangle. So because I know that OA is equal to OD, I can therefore conclude the triangle ADO is isosceles. If it's an isosceles triangle, remember your theorem, that means the two base angles are equal to each other. That means that the angle here and the angle here must be equal to each other. The three angles in the triangle have to add up to 180 degrees. So what I would say there is, right, I know that those two angles, if that one's a 60, then 180 minus 60 gives me 120. So I know that those two angles have to add up to 120. Clearly 120 divided by 2 is equal to 60 degrees. So happy days, I can say that the angle OAD is also 60 degrees. So my conclusion would be that therefore the angle OAD equals 60 degrees. In fact, it's actually an equilateral triangle as well. But the key is, now I know that this is a 60 degree angle. So let's just take a step back from the entire diagram now. I know that the angle, let's look at the triangle ABE. Ultimately, I'm looking for this angle. I know that the triangle ABE, I know two angles in it, I know two of the three angles, so it's relatively straightforward to get the other one. This is 90 degrees, this is 60 degrees, so clearly I'm going to be able to work out this one. So now I can just say, right, well, the angle BEA, it's obviously 180 degrees minus this angle, or in other words, 180 minus 90 minus 60. So your final answer in this case is that the angle BEA is equal to 30 degrees. So I hope all of this makes sense. If you're unsure on any of that, or you'd like me to clarify it, make sure you send me an email or let me know in class, and I'll try and explain it differently.